Hi folks, Dan here with Main Sheet Solutions, and today I'm going to tell you about how to calculate a center of gravity in the context of a bill of material. So the concept of a center of gravity is actually a fairly simple concept. It's a weighted average. But calculating it in a bill of material sometimes can be complicated, especially if it's a complex bill of material with several levels of indenture. So I'm going to demonstrate here. Thankfully, we have this weighted average function that exists here in our Main Sheet Solutions BOM Tools Suite. And so we have this BOM here that has a mass column. And you see we have three columns for centers of gravity. We have the center of gravity with respect to X, Y, and Z. Okay, so what we're going to do, we're going to click on the weighted average, and we're going to select the first parameter. The first parameter is the mass, and then the second parameter is the actual moment arm, and that's going to be the actual center of gravity. In this case, we're going to use the x-axis. And you notice here we have the symbolic formula here showing in the form. And it's useful to make sure that we have selected the correct columns, or the first column is the parameter, the second column is the moment arm. So we want to make sure that the mass, in this case, is both the numerator and the denominator. And the center that we're looking for is the moment arm, and that is the center of gravity with respect to X. So once we've verified that, we're going to click on Insert Equations. And we have a pop-up here, and it warns us that this tool is going to populate three columns to the right of our table. So we just confirm that, and there you have it. It populated that. So I'll describe what these columns are. The first column, this is actually the moment column. So that is the product of mass times the center of gravity. So in this case, it's the center of gravity with respect to the x-axis. So we can see here, and this is a roll-up of all those centers. So I'll do a quick formula audit here for you. So we'll take a look at these guys. You can see that it's the product of mass times center of gravity for each one of these, and it's getting rolled up to this subsystem. And you can see all the subsystems are getting added up to the system level. Okay, so that is a roll-up of all the moments. The next column is a roll-up of the mass. And so I'll do a formula audit there, and you can see that the subsystems are all grabbing, they're adding up the mass, only the mass column. Okay, the last column is the weighted average. And we could just as easily call it this, the center of gravity with respect to X. In this particular case, we can see we've calculated at the system level, at the and the subsystem level here, the subsystem level here, basically at every parent level. And you can see I have highlighted the parents here using the BOM Tools Suite with the highlight rows. I've also grouped them so you can see the centers here. We have the center at the top level, the center for this particular subsystem. This is where the center of gravity is, etc. So for the subsystem B, the center of gravity is -7. Subsystem C is 1.2, etc. So there you have it, folks. This tool can be used to very quickly give you a center of gravity. And it also rolls up your mass pretty conveniently. You can use this for the X, Y, and Z axes, or you can use that functionality for really any weighted average. I hope you find this useful. It is one of several functions that we have here in the BOM Tools Suite by Main Sheet Solutions. Thanks for watching.